The title of my presentation is FSHD, What's the Ducks For? Before I get too involved in the presentation, I just want to take a moment to briefly explain what FSHD is. FSHD is the short form for facioscapulohumeral muscular dystrophy. I'll refer to it just as FSHD throughout the presentation though. So FSHD is one of the most common muscular dystrophies, with an estimated prevalence between 1 in 15,000 to 1 in 20,000. Like most muscular dystrophies, FSHD is a progressive deterioration of skeletal muscle. It's usually associated by loss of muscle in the face, scapula, and humerus, as is implied by its full name, making things such as smiling, speaking, raising your arms above your head very difficult for those with FSHD. However, it's important to know, and I really want to stress this point, is that muscle loss is not contained only to these areas. The muscle loss can progress to include the abdominals, the hip flexors, and the anterior leg muscles, making walking difficult for people with FSHD. This results in 20% of people ending up with a wheelchair. In addition to the skeletal muscle effects that FSHD has, there's also several extramuscular problems associated with FSHD, and those include impaired lung function, irregular heartbeats, hearing loss, retinal problems in the eye, all of which further decrease the quality of life for those with FSHD. There's currently no treatment or cure for FSHD, and it's important to note that FSHD does not respond to other treatments for other muscular dystrophies, such as Duchenne's muscular dystrophy or limb-girdle muscular dystrophy. And something that I want the audience to sort of keep in the back of their head as I go through the science part of FSHD in the first part of my presentation is that FSHD truly does rob people of their mobility independence and their spontaneity. So FSHD was first described in the literature in 1884 by two French neurologists. However, it wasn't until 1990, with the publication of this paper, that the genetic basis for FSHD began to be unearthed. So in 1990, it was discovered that FSHD was localized to chromosome 4. In 1993, it was discovered that in FSHD, a deletion or a contracture of these 3.2 kilobase pair units on the chromosome 4 was what was responsible for FSHD. And these repeat units were referred to as D4Z4 repeat units. However, researchers weren't entirely convinced at this time that loss of these D4Z4 repeats was actually what was causing FSHD. The DNA contained on these repeats was thought of as junk DNA. It was non-protein coding, and the research community wasn't sure that this was actually what was causing the pathology associated with FSHD. In 1999, though, to the dismay of many researchers, the publication of this paper showed that there was indeed a function of these D4Z4 repeats, and that these repeats contained the DUX4 gene, and that the DUX4 gene actually was being transcribed in FSHD patients. So this discovery here led to the next 10 to 15 years of research looking at the implications of the D4Z4 repeat deletions in FSHD, along with the role of the DUX4 protein. So this slide here sort of has a very crude animation of the genetics that's going on in FSHD at the DNA level. So this is a drawing of the DUX4 protein contained on a D4Z4 repeat on chromosome 4. So in a healthy or a control population, there's 11 to 200 of these D4Z4 repeats on chromosome 4. However, in an FSHD population, there's only 1 to 10 of these D4Z4 repeats. So what's the consequence of these lack of repeats in FSHD? So in a control population, DUX4 is silenced by a prison of the D4Z4 repeat arrays. So like I mentioned in the previous slide, in a control population, or those without FSHD, there's 11 to 200 D4Z4 repeats. And the function of these D4Z4 repeats is they repress or don't allow the transcription of the DUX4 protein. This mechanism of silencing genes by locking them in a prison of repeat arrays is conserved across evolution. So there's numerous examples in the human genome of genes being repressed by being inside of these repeat units. So to reiterate this slide, in a control population, DUX4 is silenced by a prison of D4Z4 repeat arrays on chromosome 4, ranging between 11 to 200 D4Z4 repeats. In FSHD, though, there's derepression of the DUX4 gene, and this is caused by a lack of the D4Z4 repeats. So if you remember 2 slides ago, I spoke about how in FSHD, there's actually a loss of these D4Z4 repeats. So in the FSHD population, there's only 1 to 10. And what happens then is that the DUX4 gene can be transcribed, leading to DUX4 protein expression in FSHD skeletal muscle. So together, then this research led the FSHD community to sort of a consensus, believing that 1 to 10 D4Z4 repeats on chromosome 4 causes derepression of DUX4 and thus expression of DUX4 protein in FSHD muscle, resulting in the muscle deterioration associated with FSHD. However, what challenged this consensus was the observation of those that had FSHD but had more than 10 D4Z4 repeats. So this type of FSHD became known as FSHD2. So in 2012, what was causing FSHD2 was finally known. So usually there is a gene coded for on chromosome 18 named SMCHD1 that binds to D4Z4 and allows it to repress DUX4 expression. However, in FSHD2, there's a mutation on chromosome 18 resulting in loss of SMCHD1, meaning that the DUX4 protein can be transcribed independent of the number of D4Z4 repeat arrays. So following all of this research, 130 years after FSHD was first described in the literature, finally there's been a consensus as to what is causing FSHD1 and 2. So both of these disorders are caused by the expression of DUX4 in skeletal muscle. The only difference between these two disorders is that in FSHD1, it's the loss of the D4Z4 repeats on chromosome 4 results in DUX4 expression. However, in FSHD2, it's a mutation of SMCHD1 gene on chromosome 18, which results in the DUX4 expression in skeletal muscle. So overall, though, it's the expression of DUX4 in skeletal muscle is what's causing FSHD, whether it's FSHD1 or FSHD2. So now that the genetics behind FSHD are for the most part figured out, the question now becomes, what exactly does DUX4 do in FSHD, and how does it relate to the pathology and the muscle wasting associated with the disorder? So one study looked at the DUX4 expression in zebrafish, and it showed myofiber degeneration, as you can see in the picture on the bottom right with the orange arrow. And the same study also showed that DUX4 in zebrafish increased apoptosis, so that's cell death or loss of muscle cells, which is indicated by the caspase-3 upregulation in the DUX4 muscle, and the centralized nuclei and loss of fibers, which is indicated by the DAPI stain, which is the second orange arrow. DUX4 DUX4 expression in myoblasts has been shown to cause muscle atrophy, or loss of muscle, or shrinking of muscle, which is indicated by the orange arrows looking at the picture, the fluorescent picture of myotubes and DUX4 expressing myoblasts, and in the graph on the right side of the screen. DUX4 may also impede normal muscle regeneration and differentiation, along with repressing the glutathione redox pathway and increasing sensitivity to oxidative stress, all of which are believed to play a role in FSHD. There's obviously lots of room in the FSHD research. There's new things that need to be looked at and discovered, and with new technology and passionate, excited researchers out there, these questions will hopefully be answered in the next few years. So some of those include what epigenetic factors influence DUX4 expression, what's the involvement of chromosomal haplotype, what's responsible for the variable onset and severity, what are clinical biomarkers that can be used for rapid diagnosis, and what are potential therapies. So now the second part of my presentation kind of steps out of the laboratory, away from the petri dishes, away from the microscopes, and focuses more on the human aspect of FSHD. So the next little bit of my conversation, of my presentation, was taken from a few of my conversations with Kaylin, who has been diagnosed with FSHD, and it was really an eye-opening experience for me to get to actually to speak to her, and like I said, to kind of remove myself from all the signaling pathways and all of the DNA and the RNA and the protein expression in FSHD, and realize that these muscle biopsies that we study, they come from somebody. And I think it's really important as researchers or even healthcare professionals to realize that these disorders that we study or these disorders that we diagnose affect people. And that's the reason why I'm including this second part of my presentation. So one of the first questions I asked Kaylin about was, how are you diagnosed? How did you know you had FSHD? And she said it really wasn't until she was sitting on the floor with her legs out in front of her, and she realized that she couldn't lift her right leg up, that something was wrong. So when she went to the doctor, she finally got her diagnosis. The doctor said to her, well, if you're going to have MD, FSH is the kind to have. That is a very, very, very trivializing comment to make to somebody that you've just diagnosed with a genetic muscle wasting disease. And like Kaylin said, this lack of FSHD, the trivialization of it, most likely comes from the lack of knowledge regarding FSH in the medical world. They really don't understand how severe FSHD can get. They think of it more as just a disorder on paper. Oh, it only affects your face, your scapula, and your humeral muscles. Not that big of a deal. But as I hope you've learned from this presentation, and as most of the literature states, it can happen at a much younger age, and it can be much more severe than most medical doctors or healthcare professionals might realize. So this is just a picture of Kaylin here, a little while after she was diagnosed. I thought I'd include a picture. Another question I asked Kaylin about were, what are the biggest losses and the challenges that you face with FSHD? And what she spoke about was the fact that because FSHD is a progressive muscle disorder, you're constantly dealing with the loss of something. So whether that's the loss of an activity you can do or a movement, every day you're essentially dealing with a new disease. So you have to learn to live with a constant grieving process. And as you can imagine, that's very emotionally taxing. So in addition to the physical losses you have to deal with, you also have to deal with the sense of loss that comes along with FSHD. One of the biggest losses she also spoke about was the fact that she lost her career. So she did go to the University of Hawaii and major in kinesiology. Um, Even though the doctor told her she should just have a desk job, essentially, give up on any hopes of doing anything physical with her life. She put that all aside and got her kin degree and worked as a personal trainer. Unfortunately, it did get to the point that she was no longer able to safely train her clients. However, she has found a way to fill the void with other fulfilling things. And one is that she has more time to devote to other people that have been diagnosed with FSHD. So instead of helping people in the gym learning how to squat or to bench press, she's teaching people how to cope or how to continue living life to the fullest with FSHD. And that's something that I really gathered from speaking with Kaylin, is that she stays so positive because she learns to focus on the gains instead of the losses. And I think that that's something that I learned from her. It's something I hear all the time, that you always need to stay positive, keep looking forward. But it takes on a different meaning when you speak to somebody like Kaylin, who stays so positive, even though from the outside looking in, it may look like their life isn't is affected so greatly by FSHD. Something else that Kaylin has suffered a loss of is her ability to ride her bike as long and as far and as hard as she wants to. It does take a lot out of her, as she mentioned in the picture on the right. It leads to some days of recovery after riding her bike, which is very unfortunate. She essentially has lost the passion in her life. Something else I spoke to Kaylin about, it's something, again, I didn't really think about from an outsider's perspective, is what it's like to date when you have something like FSHD. So this is a picture of her and her husband Johnny on their wedding day. So I just want to kind of tell a little bit of a story about that, just because it's such a beautiful story, and I feel like I want to share it. So as Kaylin mentioned, dating when you have FSHD is difficult. When is it the appropriate time to explain that you have a degenerative disease? Do you do it on the first date, thinking maybe the person will never talk to you again? Do you wait until you get more involved and worry about the fallout of revealing that? And then if there is no immediate fallout, then do you have to worry about that the person really doesn't understand, and that maybe down the road when they finally get it, you'll be left alone, even after you've already invested so much in this relationship? So Kaylin met Johnny when Johnny was actually filming a Friends of the FSH Society video, and he already knew everything about Kaylin before she even really met him. And he asked her out on a date a few weeks later, and to make a long story short, they're now happily married. So it's just another thing that it was interesting to learn about and to hear about, because it's just another thing that I take for granted, not being affected by something like FSHD. And that's more pictures of them after he proposed and on their wedding day. I also asked her a question about what would you do if you had 24 hours without FSHD. And the first thing she mentioned, without much thought, is that she would want to go running. And at first I was like, you just want to go running? Like, there's so many things I could think of that I'd rather do than go running. But what she talked about was that running has a feeling of spontaneity to it. And again, this is something that I take for granted. If I wake up in the morning and I want to go for a run, I can put on my shoes and go for a run. If I want to take my dog for a walk, I can take my dog for a walk. But with FSHD, that spontaneity is lost. You don't have the ability to just wake up and do what you want anymore. So that's why she would choose running as one of the main things to do with her 24 hours free of FSHD. And lastly, I asked her, what would you want to tell? What would you want to tell an audience? You have a group of eager listeners. What do you want to say? And she said to find what you're passionate about and don't live with any regrets. what I really take from this is you can be the smartest person in the world, but people hear their words, but they feel your passion. People respond to passion. That's something that you can't fake. So if you're really passionate about something, you're more likely to have people to buy into what you're saying and want to help you and see you do good. And lastly, don't live with any regrets. And I think I don't really need to explain that very much, that she makes a very good point there, that you never know what's around the corner, and to just be the best person that you can be, and make the best out of what life has given you. So to wrap this whole presentation up, I know I've been talking for a long time, I just want to end with the thought that FSHD is a disorder of losses. So from the loss of the epigenetic repression of DUX4 due to the loss of D4Z4 repeats, to the loss of spontaneity in daily life, to the loss of some movement, some freedom, or something every day. So overall, from the genetic basics to the molecular basis to the human life basis, FSHD truly is a disorder of losing something. There is currently no cure for FSHD. However, with the advent of advancing technology and drug development, finding a cure becomes more viable each day, and hopefully the dream of clinical trials may soon become a reality. And lastly, I just want to end with the fact that there's very, very, very little funding directed towards research beyond that provided by grassroots organizations such as the Friends of FSHD Research. So this is their logo here and their website. And as you can see from the graph, that over the past few years, they've raised nearly $2.5 million that goes directly to funding research in FSHD, in the FSHD community. So if you have a chance, like them on Facebook, try to attend one of their fundraisers, or just read what they have on their website and learn more about the society and all the good that they do. Thank you for your time, and thank you for listening to my presentation.